Well, while you're waiting, let me give you a brief introduction. So, Tracy and I represent a couple of groups that are on the software-defined standards part of ONF. So most of what you hear from ONF is about the software development pieces, the development of the exemplar platforms, ONOS and OMEC and those. So we're on the standards-oriented piece of things. And we're going to be talking about work on information modeling and related testing and implementation. And so I was struck by Nick's talk this morning about how protocols are becoming sort of historical and really no longer of much interest. And my background was all in protocols and things like RSVP and you know, all these complex things you had to analyze bit by bit. You had to have like someone have a you know, a protocol analyzer to figure out what was being sent. But as he said, all that stuff is really becoming kind of historical, and we're realizing that what we really care about is the model. That is, you know, what is the information that's being sent between systems? How does one system understand what's being sent to the other? And then, you know, converting that into a protocol and putting it on the wire becomes really sort of an automated process. And you can pick, in fact, what protocol you decide to use based on what kind of characteristics do you need. Okay. So the two groups are, there's one called Open Information Modeling and Tooling, or OIMT, and one called Open Transport Configuration and Control. So I chair Open Transport Config and Control. Both of those you can find on the ONF website. And on the ONF website, you can open up the pages for them. There are links on there to things like GitHub sites where we have put the models and in some cases reference implementations. And we'll give one plug, which is we're going to be talking about wireless transport modeling, but there's also been a lot of work done on optical transport modeling. And there's going to be a talk at 6 o'clock today about the transport API and multi-layer modeling and transport API. So you might want to go to that one as well. So I'm Lyndon Ong. I'm with Ciena. As I said, I chair OTCC. And my co-presenter is Tracy van Brakle from AT&T, who has been driving a lot of the wireless related work. Okay. All right, so as I said, information modeling. So there's an issue of, you know, people can define open APIs, open models, but they can all be different. They can all be vendor specific, and that doesn't, that you know, maybe helps you a little bit, doesn't help you all the way. What we were aiming at with the modeling is actually to define as much as we can sort of commonality, a common model at the core. There's something called the core model developed in ONF, and that is basically intended to be a technology independent model. So something that can be applied to many different technologies for transport. And then the kind of process that's involved is with this core model, then you can add things like specific technology models, like a wireless transport model, a photonic media model. But they all go back to this core model for kind of the basic objects. And what's different is becomes more of the more like what particular attributes you define for the objects that pertain to wireless, what particular attributes would pertain to photonic media or OTN or whatever. So there have been a couple of different tracks where, for example, the core model kind of branched out, and we did an implementation of the core model for transport, which was called, as I said, Transport API. There was a photonic model that was developed, which kind of combined with the Transport API has been used to support the Open Disaggregated Transport Network, or ODTN project here in ONF. On the wireless side, we defined a wireless technology model, and that work is going into not only ONF work, but also being contributed to ONAP and to ORAN modeling work. I didn't show it here, but there's also work where the core model has been tied into work in MEF on Ethernet services and ITU-T and other places. Little bit about modeling in general, and we're running late, so I'm not going to go in a lot of detail on that. But you know, the basic idea, as I said, is to define the objects that you are talking about when you're passing information from one system to another, and what are their attributes, and how do you use that information. So I think one of the things to emphasize that in the process, we're not trying to spend a lot of time defining a complete and perfect model. We're treating it as a cyclical process. That is, you define a certain amount of the model that people can start to implement it, test it, use that to refine the model, and then extend it to add features and make it more complete. And Tracy will talk about the testing process that's been going underway for the wireless transport. This is a complicated figure, but it's just to show that the information modeling work did not start kind of from scratch. There's always been an interest in defining sort of a technology-independent overlying model, going back to some work in ITU-T and TMF some time ago. And this work was picked up in ONF and also extended to MEF. And in fact, there are pieces of it that also overlap with work in ETSI NFE and ETSI 3GPP as well. I guess you might ask, why is this work taken so much time? I think it's just like I think Oz mentioned with wireless and wireline convergence, it's an idea that's been around for a while, but it's been a matter of does it match with kind of the level of technology and tools that are available to make the most use of it. This is just a picture of some of the components of the core model. It's defined in ONF Technical Reference 512. So that's available on the ONF website and also on the GitHub site. It defines very basic things, like I said, technology-independent things like a basic object called a forwarding domain, which is something that forwards things from one termination point to another. And you can define what you can do in terms of forwarding, what ports can forward to each other, what kind of characteristics it has. There are links which connect the forwarding domains. The forwarding domain can be mapped to a more complex topology, an internal topology, and then you can build kind of essentially services on top of that, which are called forwarding constructs. And then, as I said, you take this basic model and then you start adding or augmenting it for different technologies. This is an example of how it was augmented for photonic networks. Photonic networks kind of differed a bit from previous work because you were modeling really two things. You're modeling the channel, the photonic channel, media channel that's being created across the photonic network, and then the transmitter receiver at either end. So these are really kind of two separate things. You create a transparent channel, and then you create, then you configure the endpoints to be transmitting and receiving. Again, more of that would probably come out in Kartik's talk at 6. So a lot of that work has gone into the ODTN project. Some of that work has been tied into work at TIP as well. And so this is sort of the photonic piece of it. What Tracy will talk about more is the wireless transport piece of it and what we've been doing with that in ONF, ORAN, and ONAP.
So there's been an unofficial wireless working group that traverses multiple open source projects since I think I first met you, Lyndon, in 2015. And that's when we discovered that the ONF Common Information Model did not have a package for air interfaces. So the first thing we did, we meaning AT&T, Telefonica, Deutsche Telekom, Bell Canada was involved at one point, Orange, is we worked with a bunch of wireless transport equipment vendors to develop a conditional package to configure and control air interfaces. Now that's great, but as operators, we need to verify, validate, or I think Nick McCune said, do the boring stuff, make sure it works. So we've been having proofs of concept, plugfests. Now we have an actual pilot, and we're doing work, AT&T, we call it a production innovation zone, to actually get this behaving itself in a live network with appropriate safeguards. So the model is great. We are very pleased about the progress, but we want it to actually get realized in our network. So a POC we did not too long ago, and this is where, again, Wireless Working Group traverses multiple open source projects and communities. So we took the ONF model with the extension for the air interface that was formalized as Technical Reference 532 within the ONF. We integrated it with a Linux Foundation Open Daylight controller, which is also an ONAP controller, and within AT&T's network, it's also an ECOM controller. And we got a bunch of wireless equipment vendors, Ceragon, Ericsson, Huawei, Intercom, NEC, Nokia, CI, ZTE, just to name a few, to actually support this. It was a rather simple netconfig management interface to do simple things. But, it was a powerful demonstration from an operator perspective. So now we're at the point, and again, we've been at this since fourth quarter 2015, and we do a proof of concept the first week of December, the last week of June, every year. Again, we as a bunch of operators with sympathetic equipment vendors. So now we're working on a pilot to, we don't call ourselves Wireless Transport Project anymore, Lyndon. Now we're fancy. We're the 5G X-haul, front haul, back haul, mid haul, fill in the blank haul, do some network automation. And you'll see that we're working on a set of complementary information models that are expected to be open sourced within the ONF and are also being used within ONAP, ORAN, and some other O thing that I don't remember right now. This joint 5G X-haul SDN pilot, AT&T, Deutsche Telekom, Telefonica. I just got word that Orange is going to join us, and we will verify, validate what works, what doesn't work with these new models. Our goal, of course, is to get to the point that we can actually attain a respectable degree of end-to-end programmability across a multi-vendor 5G network. And of course, that's not just RAN, it's not just, X-haul. I don't go too close to core because that's too complicated, but it's, transport and RAN, that I can handle. So this is all of us in Telefonica's office in Munich last year. And now, of course, it's not just wireless X-haul. We are taking the air interface and other, this is a class diagram that was borrowed from 3GPP's 5G network resource model. The color-coded boxes are the ORAN entities that do not pre-exist in 3GPP. So we're filling in the blanks, because if you look at anybody who looks at the 5G network resource model, it's got a lot of blanks, so that we can, again, come up with an information model that can be used to generate UML, that can be used to generate a Yang data model, and that can be the foundation, because it's all foundational, of management interfaces in a unified M-plane, management plane specification for the 5G network. So the things that are color-coded are not in 3GPP today. They're being defined, developed, and modeled with Lyndon's help, who's a co-chair of the modeling subteam within the Open RAN Alliance. So now when we have our model, it's great to have a model, but you have to bash it and do a plugfest and have a proof of concept. We're in the process of planning our next proof of concept, which will take place, again, first week of December 2nd. And we'll take not only the ONF, but also the ORAN configuration management interface specifications, again, truly open. We'll integrate with, this is the ORAN reference architecture, but because we're AT&T, the service management and orchestration happens to be ONAP, so many acronyms. And we'll do some interesting things with a simulator. We'll have simulated DU-RU as well as real equipment. And our focus will be the use cases that are getting developed within another acronym, the OSC, the ORAN Software Community Release A, codenamed Amber. So proposed use cases, nothing too difficult because this ORAN software community, this OSC Release A, it is our first release. So we're going to pick a few tried and true ONAP 5G use cases that not accidentally are 3GPP aligned, PNF plug and play, PM bulk requests. I just see Ericsson walked in. This is something that Ericsson contributed. PNF plug and play is from Nokia. And basic fault, and I think more interestingly, the ONAP optimization framework, that's what OOF means, based 5G SON use cases. So I put a little footnote at the bottom. This may include additional ONF entities if it makes sense to, because I was next door speaking with the folks who are working on something that looks a lot like near real-time RIC and happens to be ONOS-based. So it's all about, you're not going to develop everything you need within a single open source project or open source community. And you absolutely, this is one thing I learned early on, you want to minimize rivalry. Competition is good, but rivalry among your suppliers is not always healthy. And rivalry among open source projects and open source communities can be toxic. So you definitely want to harmonize. So this is a quick example or a quick description of the message flow for PNF plug and play. And you'll notice that down south where we have our O1, O is kind of short for OANM. It's a netconfig configuration management interface. There are multiple examples of this for wireless and or wireline backhaul, as well as ORAN PNFs, physical network functions, and of course VNFs, but VNFs are last year's news. This is kind of my favorite, more complicated, interesting use case. This one is an example that, PCI optimization. But earlier today, we heard a very good talk about, one part of the keynote, about, how do you succeed with closed loop automation with real verifiability. And this is a step in that direction. And again, we're bringing in elements from ONAP, Open Daylight, OPNFV, ORAN software community, O this and O that. So issues and next steps. And Lyndon, I think I'm trying to speed up here because I know how are we doing? Okay. Okay. So this is just a partial list. A big problem with all of this modeling is there's actually a plethora of models, and so many of them are different and mutually incompatible. So we really like, and I'm saying we, because I'm one of several service provider operator representatives who've contributed to this. Telefonica, Orange, and Deutsche Telekom people couldn't be here today, but we really like the discipline of an information model and traceability back to it, but then maintaining consistency and forward and backward compatibility from the information model to UML to Yang and back, is non-trivial. So here's where we'll be asking the ONF to help us. There used to be a UML to Yang tool that was incredibly useful, and I don't think it's supported anymore, but I'm expecting we'll ask ONF to work another miracle. And I already talked about this, the second bullet, there are way too many information models. It's great to have the notion of information models with, network domain or equipment specific, conditional packages or packages to support, vendors' innovation that may be proprietary. But, we are very, very keen on reconciling these open information models across all of the open source projects. So we don't want to get an open interface from open source project 1 from vendor A, and then vendor B supports the open interface specification from open source project 2. Prosumer relationships, as I mentioned when I showed the evolving ORAN class diagram, that was sourced from 3GPP network resource model, but we're adding to it. So ORAN, which is, it's not exactly an open source project or community, it's kind of like an open industry consortium, will be, contributing back to 3GPP, and 3GPP is going to be contributing back to us. So how to manage that, I called it the prosumer relationship. I think I omitted a double quote, is also, non-trivial. And there are a bunch of other issues and next steps that I'm not going to go into. I should mention that the tool we're using for information model development is Eclipse Papyrus. It's open source, of course, and it's the same, Eclipse Papyrus project is the same thing that, I learned this from you, Lyndon, and ONAP also uses Eclipse Papyrus, as does 3GPP. So we're also interested in, I should have added that as another next step, making sure that Eclipse Papyrus is, continues to get the strong support that it has been getting from the open source community. And so far it seems that it is. So I think we have a couple of minutes if anybody wants to ask a question, not one that's too hard, otherwise I got to call Lyndon back. Okay, thank you very much for your time, and bye-bye.